Hello everyone, welcome back to our channel. Today we are going to solve contains duplicate problem. So here the question is given an integer array nums, return true if any value appears at least twice. At least twice means minimum 2 times and more than n number of times. So if any value appears at least twice in the array, we need to return true and we need to return false if every element is a distinct. We can understand the question clearly by following through examples. So here in the example 1, the input nums is 1, 2, 3, 1. So here you can see like 1 appeared 2 times. So the output is true. And in the example 2, nums is 1, 2, 3, 4. Like here all elements are distinct. That's why output is false. We can check the possible approaches to solve the problem. So let's try to understand the first approach. So I'm writing like nums array elements here. Nums array is 1, 2, 3, 1. So in the first approach, we'll try to solve with the brute force approach. So usually in the brute force approach, what we are going to do is like we'll take one element and we'll compare with the all the remaining elements. Let's say here in the first iteration, we will compare with 1 with 2 and 1 with 3 and 1 with 1. So 1 with 1, there is a match. So we need to return true for this case. So for this case, we can say like we can exit from the loop and we can say like we have a duplicate element. Let's take another example, 1, 2, 3, 4. So in this example, let's say like first we need to compare with the 1 with 2, no match, 1 with 3, not same, and 1 with 4, not same. So now we need to traverse the loop and we need to check for second element. For second element, we need to check for 2 to 3, not same, 2 to 4, not same. So now we need to traverse the loop for third element. So in the third element, this is 3, we have to check for 4. So no match. Now we need to go for final element. Final element is this is the last element. So we can say like there is no match at all in the array. Means there are no duplicate elements. So all elements are distinct. So we need to return output as false in this case. So quickly we can write the brute force loops so that like we can estimate the what is the time complexity of for this approach and space complexity. So let me write like as we all know like for brute force like when first we need to write the outer for loop. So in the outer for loop we are just traversing the loops, traversing entire array, and after that we need to take the inner for loop. Here what we are going to do, we are just comparing with the remaining elements. That's why like our j has to be start with I and j less than n, j plus plus here. So the logic is like simple, like if my nums of I equals to nums of j, means the numbers are same, means it's duplicate. We have duplicate, that's why we need to return true. So we need to check for all the elements. Whenever we got the duplicate element, so the loop will break and we got the answer. So until unless like for all the traversal there is no matching element, what we need to do, we need to simply return false. Means like all elements are distinct if we are return false. So this is the simple brute force approach. So here we can estimate the time complexity. So time complexity, like we know, like for single for loop, we need to traverse the entire array. Let's say like array size is n. Then we can say like for single traversal, we need to take O of n time. But here in the brute force, for each element, we need to check with the remaining elements. So we need to traverse the second loop for remaining elements, right? That's why total time complexity for this approach is O of n square. And coming to space complexity, space complexity, like we are not at all taking any extra copy of arrays or anything. That's why space complexity for this approach is of 1. So this is quickly like about brute force approach. So if you see like time complexity is of n square, so which is not a optimal way. So let's discuss like possible approaches, um, remaining possible approaches. So let me quickly erase this one. So now we'll discuss about the second approach. In the second approach, we are following with the sorting mechanism. Like with the sort, we are going to solve. So here numser is 1 2 3 1. So you can apply like any kind of sort, like quick sort, merge sort, or any kind of sort you can take, and you can sort this one in ascending order. After applying sorting mechanism, like now nums array look like this, like 1 1 2 3. So now how can we check like does this array contains duplicate or not? Simply by checking the adjacent elements. Here, if you say in this scenario, like one with one, we are comparing with the one. So we can say like these two elements are same, means we have duplicate. So now we need to return the true. But if we take like our second example, 1 2 3 4, already it's in ascending order. So after sorting also, it's like for this one there is no need of sorting, but to keep in mind, like we need to pass all edge cases, so we'll apply sort. So that's why like 1 2 3 4 is the output. So here let's try to compare with adjacent elements. For 1 with 2, no match, and 2 with 3, no match, 3 with 4, no match. So we can simply return false, means all elements in this one as distinct one. So with this approach, let me quickly write down the snippet for this one. Like we need to traverse the whole array. This is like first we need to apply the sorting mechanism, sort for nums array. After that, we need to traverse the whole loop. And here is our main logic. What it is like, we need to check like my nums of I and its next element, nums of I plus 1. If these both are same, we need to return true. For full traversal, we are not finding any duplicate elements. If we are unable to find any duplicate elements, then we need to return false by saying like this array is having all distinct elements. So this is the super straightforward answer. So let's quickly calculate time complexity and space complexity for this one. So coming to time complexity, we are using like only one for loop. So we can say like WAF and uh, entire array traversal, and we have used sorting mechanism. So for sorting mechanism, like we have to say like log n. So whole like time complexity is of n log n. And space complexity, we are not using any extra space or arrays, so that's why space complexity is of 1. So this is the sorting. Now we'll try to figure out like which the best optimal approach for this problem. So we'll discuss about our third approach. In the third approach, I'm going to use the unordered set. So this is the nums array, and going to use the unordered set for this approach. So here, what we are going to do is like, let's assume like this set looks like one of container. So this is my container. So what we are going to do is like, we traverse the array and we pick the element, and we'll check in the set container like is this element already present or not. If present means it's a duplicate element. If not present, we will insert into the container. So first time, like in the traversal, we are at 0th index. First one element is 1. So we will check in the this set container. So container is empty. So no values are there. So we are just inserting 1 2 here. After that, in the traversal, we got the element 2. So we will check only 1 is there. there are no twos in the container to say it's a duplicate. So there are no twos. That's why like we will insert into the container. After that 3, so we will say 3. 3 also not there. That's why like we are inserting the 3 also. After that 1 came. So already we are checking like 1 is there, right? So we can straight away like we say like it's a duplicate element. 1 is. So in this approach, what we are, if we estimate the time complexity and space complexity, time complexity is like we are just traversing only once in the nums array. That's why like we can select time complexity is O of n, and space complexity like we are taking one unordered set. So if the elements all are distinct, so this size of this container also like whole array size. That's why like in the worst case we can say space complexity is O of n. So when we are handling with the large data sets, this approach is a very optimal way, and using this approach we can get the efficient results. Let's quickly code for this approach. So let me take one unordered set, which is integer type, and set name is I am taking like as visited, because every time we need to check like that. We need to check like if that element is present or not in the set. After that, taking one for loop, size I plus plus. So for every loop, what we have to do, we need to check if that element is present in the set or not. So how can we check? By using the count function. If of visited dot count of nums of I means like if count is returning greater than 0 value, means like already that duplicate is existed in the set. That's why we need to return true. And we need to insert the values into the set. So after full traversal, if there are no duplicates, we need to return false. Let me quickly run this snippet. Typo error, so nums array. You can see like I got one compiler error, nums. Yeah, our solution got accepted. Let's try to submit. Yeah, like all test cases got passed. I hope you understood the problem clearly. Please do like our channel, and thanks for watching.